In this video, we are going to cover the intuition, visual proof, and definition of the circle, so we can have a visual understanding and answer the question how we can generate one. As a first step, we will try to have a visual understanding of the basic standard definition, which most of you are familiar with. So let's see it graphically. Talking to the ones who just want to see the end result, here is a brief summary. Later on, I'm going to guide you through step by step. As a second step, we are going to break down how we construct the parametric form. Again, talking to the ones who just want to see the end result, here is a quick preview which we are going to break down. Starting with our standard equation first and following the definition, one of the cornerstones is the following. A circle is a set of points equal distance from the center. Set our center to -4 and 4, define a set of points. We can call them V because they are more like vectors in mathematical terminology, but for all matter and purposes, you can call them points as well. The distance difference from the center can be defined as V minus C, yielding the blue R radii vectors for points. Note that R0 vectors have the same length and direction, only shifted by the center. The distance is measured by the Euclidean distance based on the Pythagorean theorem. As the red, green and blue line form a right triangle, the square length of R is the sum of the square length of the red and green line respectively, which is the square of x and y component, the V minus C vector, which yields the equation of the circle, keeping the promise of the definition. Here you can see all the components making up the circle. But you could ask what keeps this equation bounded limited. So if I choose an x, how can I get the y component generated? X and y are bounded by the length of r, otherwise visually or mathematically our root would be undefined. We've shown that the equation of a circle is nothing else than keeping all points equal distance from the center by measuring the Euclidean distance point, which is nothing else than using the Euclidean theorem formed by the center, x and y components of this point. If you missed anything, please let us know in the comments. As a second step, we are going to break down how we construct the parametric equation. Addressing the viewers who just want to see the end result, here is a quick summary which we are going to break down in the following steps. Let's draw a line, length 1, from the origin. As the line makes a right triangle with x and y component of r hat and the origin, observe that by definition, x component of r hat is cosine theta or the ratio of the adjacent side and hypotenuse. Y component of r hat is sine theta, which is the ratio of the opposite side and hypotenuse. Note, we can also see the trigonometric identity working here. Using the Euclidean distance and Pythagorean theorem, you can see that by definition this is true. Repeat this for any angle, where angle being our input parameter, and note that the same applies for any of the line length 1 from the origin. These points, vectors or lines, not relevant how we call them, as we only apply simple operations on them, make up our inner circle, which can be parametrized by the angle yielding the parametric form of a unit circle centered around the origin. Now let's scale up our length 1 r hat line by a new radius we can call vector r instead of at r. We will do nothing else, just scale up all sides, triangle made up by x and y component of r. So x component of r vector is just cosine theta, or x of r hat scaled up by a scalar. Y component of r vector is just sine theta, or y of r hat scaled up by a scalar, which generates us the outer circle centered around origin, any radius determined by an arbitrarily chosen k, instead of using the parametric form. Now let's shift the center arbitrarily, translate the center by adding an offset of -4 and 4, which means we just move our coordinate system from the center by adding -4 and 4 to every point we calculated so far. And an offset to all of the points. X component of v vector is just x of r vector shifted by -4, or x of r hat multiplied by 2 and shifted by -4. Similarly, y component of v vector is just the y of r vector shifted by -4, or y r hat multiplied by 2 and shifted by 4, which generates us the offsetted circle by a and b, yielding the parametrized equation of the circle. Thank you for watching.